This is problem number 5 from the sample test problems for test number 3. Convert between polar and Cartesian rectangular coordinates as specified. A, find Cartesian coordinates for the point with polar coordinates 2, pi over 3. Okay, so first thing I'm going to do is plot these. Suppose you don't need to, but we'll go ahead and take a look at it just for practice. So it says that the distance from the origin is 2, and you're going to go at an angle of pi over 3. So an angle of pi over 3 is somewhere up here. And we're only going to go 2 units away from the origin, so maybe it's here, I don't know. So this is our point, 2 and pi over 3. And so let's see if we can't find the values of the x and the y. So we've got some formulas here. We know that x is r cosine of theta, and y is r sine of theta, where the 2 is your r and the pi over 3 is your theta. This becomes 2 cosine pi over 3 and 2 sine of pi over 3. Now, if you see an angle that's familiar, like pi over 3, assume that I'm looking for an exact kind of thing on the unit circle as opposed to typing these things into the calculator. So go ahead and check out the unit circle. I think that the cosine of pi over 3 is 1/2. So this is 2 times 1/2. And the the sine of pi over 3 is √3 over 2. So we get 1, and we get √3. And of course, you're welcome to type it into the calculator, but one of them will give you a decimal that you don't recognize. 2 cosine of pi over 3. Again, if you hit sine, cosine, tangent, make sure you think about the mode. We're in radians, that's a good thing. So we hit enter and we get 1. But if we do second enter and change cosine to sine, and we'll get some messy decimal, which I'm assuming that most of us don't recognize as being square root of 3. Okay, part B. One last thing about part A. What that means is that the coordinates of this point here in terms of x's and y's is 1 and then square root of 3. 1 to the right, square root of 3 up, and you land on the same point described by the r and the theta. Part B, find polar coordinates with Cartesian coordinates, -2 and 1. This one I really do think you need to plot the point. So we're going to -2 and then up 1. So we're looking to land over here. And so the reason that I like plotting the point here is that I want to make sure that the angle that I'm given makes sense. That whatever theta I come up with is something in the second quadrant. So let's see what happens. The formula is going this direction. R is equal to the square root of x squared plus y squared. Theta is equal to the inverse tangent of y over x. Where your x is -2 and your y is 1. So let's plug in. -2 squared plus 1 squared is 4 plus 1 or 5. So the square root of 5 is the r. And here we're looking for the inverse tangent of y over x. 1 over -2. 1 over -2, I feel like that's a unit circle thing. Recognize that tangent is a little bit difficult to read off of the unit circle. You're looking for a point where the ratio of the y to the x is 1 over -2. And actually, I don't think we're going to find one. I don't think that this is a nice angle. If it were inverse sine or inverse cosine of -1/2, then I think we could find it on the unit circle. So look on the unit circle, then give up when you can't find it. And we'll type this into the calculator. Inverse tan of 1 divided by -2. I get -0.463. Again, thinking about the mode, the calculator just gave us an answer in radians, which is fine. -0.463. Where is -0.463? Okay, so for radians, we've got a couple of special ones I'd like you to know. Up here at the top is pi over 2, which is like 1.57. Over here at the left is pi, which is about 3.14. At the bottom is 3 pi over 2, which is like 4.6-ish. And so I'm interested in knowing where, I guess closer to 4.7, right? 4.7-ish. I'm looking for the angle that we just found on the calculator. It was negative 0.46 radians. And so we're going negative, so we're going clockwise. And if we go clockwise 0.46, well, let's see, if we had gone counterclockwise 0.46, we would not have gotten up to the 1.57. So we would have landed somewhere in the first quadrant. So let's say this is around 0.46 radians, the positive version, but we're going negative, so the negative version is down here. And is that the answer? Is the point we're interested in, that one up there in blue, is it down there in the fourth quadrant, which is the angle the calculator is giving us? And the answer is no. But the calculator is programmed to just give you the answer in the fourth quadrant, and you need to have the sense with the picture in front of you to say, oh, that can't be the right answer. We need to find the corresponding angle in the second quadrant. Okay, but just thinking about the symmetry of the circle, or the symmetry of the graph of the tangent function, or just looking at my picture, if it's negative 0.46 here, feels like there's a real good chance that that 0.46 can get copied there. So the angle that I'm actually interested in, theta, is really pi minus 0.46. So we'll type that into the calculator. So the real theta is about 3.6 radians. So ultimately, this point right here is also known as r and theta, radical 5 and 3.6 radians. Let's see. Convert the equation r equals 2 secant of theta to rectangular coordinates. Okay, I see that I have an equation up here at the top with an r and a cosine, and another one with an r and a sine. I don't have anything with a secant. So it feels like a very natural thing to try first is to replace that secant with 1 over cosine. All right, and having a cosine in the bottom isn't super, so how about we multiply both sides by cosine, and we get r cosine theta equals 2. And then finally, r cosine of theta. This is kind of a mini miracle that's happened here. R cosine of theta is something we've seen before. R cosine of theta is also known as x. And the goal here was to get x's and y's, so we just won. The equation is really the same as x equals 2. So if you were to graph on your calculator or on some other software, the original, r equals 2 secant theta, you would end up getting a vertical line, x equals 2. Part D, convert the equation y minus x equals 1 to polar coordinates. Express your answer in the form r equals f of theta. Okay, here, how about we just go ahead and replace the x's and y's using the same two equations we've seen up here. So instead of y, r sine theta, minus, instead of x, r cosine of theta, and that's supposed to equal 1. Ultimately, the goal is to get r equals, so I feel like those two r's need to compress down to a single one. We can do that by factoring out the r. And then we'll divide both sides by the stuff in the parentheses so that, again, we can get r by itself. So that's our equation in the form r equals f of theta.